Hi, Mr. Eckert here. All right, we are. Let's see, you're recording. Yes, we're recording. Um, okay, so I'm going to cover the non-calculator practice test 1, part 2, starting with problem 6. So we have this graph here. And it says in the xy plane above, the red line is parallel to the blue line. What is the value of p? Okay, so we're going to find first the slope of the red line. And then we're going to set it equal to the equation for the slope of the blue line and then solve for p. All right, take a look. So we have our slope, the red line, is going to be 3 minus 0, the y coordinates, over 0 minus a negative 2, which is going to equal 3/2. That's my slope of the red line. Okay, so now we're going to set that equal to the slope of the blue line. 3/2 is going to equal the y coordinate 0 minus negative 3. Over the x coordinate p minus 0. Okay, which is just going to equal 0 minus negative 3 is positive 3. P minus 0 is just p. So from this, we can say 3 equals 3, 2 equals p. Okay, so our solution is p equals 2. All right, and let's go back and check this. That would be solution A. Okay, go down, and we are correct. Solution A. Okay, problem number 2, or problem number 7, rather. If x to the a squared over x to the b squared equals x to the 36th power, I got to make sure to have my full throttle. Then x is greater than 1, a plus b equals 9. What is a minus b? Okay, so when we're dividing exponents with the same base, we can actually subtract the exponents. So we can rewrite number 7 as follows. So we can say x to the a squared minus b squared equals x to the 36th power. From here, you can see that we can rewrite this. If we remove the bases, we get a squared minus b squared equals 36. We're given that a plus b is 9. So notice on this side, this is a difference of squares. We can factor it into a plus b times a minus b equals 36. A plus b is 9, so we can have 9 times a minus b equals 36. Divide both sides by 9, we get a minus b. A minus b equals 4. So that's our solution, which is b. Scroll down. Yep, we got it right. Nice. Okay. Problem number 8. All right, so we got n times a equals 360 degrees. It says the measure a in degrees of an exterior angle of a regular polygon is related to the number of sides n of the polygon by the formula above. If the measure of an exterior angle of a regular polygon is greater, that should be once, is greater than 35 degrees, what is the greatest number of sides it can have? So to figure that out, we want to divide 360 by 35 and then round down. Problem number 8. So we're going to do 360, divide it by 35. That's going to be, let's see, we got, take out my pencil here and do some long division. You won't be able to see this. Sorry about that. So 35 goes into 360. It goes into 36 once. We have 10 left over. Doesn't go into that. So it's 10.2 roughly. Let's do an approximate symbol. We have one. So it's approximately 10.2. We're going to round down. So the most sides that this regular polygon can have is 10 sides. Let's go back here. So we're going to pick solution C. Go down and check. C, we're good. All right, problem number 9. The graph of a line in the xy plane has a slope of 4 and contains the point 112. The graph of the second line passes through the points 1, 4, and 2, 0. If the two lines intersect at the point A, B, what is the value of A plus B? All right, so a couple ways we can do this. We can figure out the slope of the second line and then set AB minus one of these points equal to that slope and solve. Okay, so let's do that. Problem number 9. Look back. Points we have, I'm going to write them down. We have the points 1, 4, and 2, 0. All right, so our slope is going to be zero minus 4 over 1. That's going to equal negative 4 over 1, which equals the slope of negative 4. Actually, I'm going to leave it as negative 4 over 1. All right, so now we're going to incorporate that point AB in there. Okay, so we'll say negative 4 over 1 equals B minus 0 over A minus 2. Okay? It's going to equal B over A minus 2. We're going to cross multiply now. So we're going to multiply negative 4 by A minus 2. And then B times 1. Okay. So we get negative 4A plus 8 equals therefore A plus 8 equals B. Okay. That doesn't quite help us just yet. But we can come up with another equation based off the first line. So first line, we have, let's see what we have for points. They give us the point 112. I'm going to write that down. I can use that and the point AB and the fact that the slope is 4. Okay. So we got that one equation. So I'm going to set this up. So we're going to have 4 over 1 equals 112. So B minus 12 over A minus 1. All right, we're going to cross multiply that. So we'll get 4 times 4 times the quantity A minus 1 equals 1 times B minus 12, such as B minus 12. So working that out, we're going to get 4A minus 4 equals B minus 12. Let's solve now. We can overlay these equations and we can subtract. Let's see. So if we have negative 4A plus 8 equals B, and we subtract from it, or we multiply this equation by negative 4 and move over the 12. Let's move over the 12 first. Get myself. So we have a 4A plus 8 equals B. Okay. Actually, we can just get rid of A. That's a good way to do it. So if we add these, 4A plus 8 equals B, we add these two together. Space them out a little bit. So we're going to get, the A's are going to cancel out. We're going to get 16 equals 2B, therefore B equals 8. Now we just have to figure out what A equals. Okay, so if we plug that back into, say, this equation here, we're going to have 4A plus 8 equals 8. Therefore, A must equal 0. So, A plus B equals 0 plus 8 equals 8. So our solution is 8. Took a little while, but we got to it, and that's D. And that is correct. Okay. And then the last one. Let's look at this last one. Which of the following equations has a graph in the xy plane for which y is always greater than or equal to negative 5? Okay. If we look at this one, this is a cubic function. Actually, let's go up to the absolute value first. Absolute value function. The vertex is at 0, negative 5. So it actually does, it's not always greater. At the vertex, it is at negative 5. So that one doesn't work. Next one is a cubic function. This one has an end behavior where it kind of comes up like that. So there's lots of points where it's below negative 5. Half of it is below negative 5, half of it's above. So that one doesn't work. This next one, C, is a quadratic function, like a shape of U. The vertex is at 0, negative 5, so it is not always greater than or equal to negative 5. Finally, this last one, the vertex is at positive 5, 0, and it opens up, meaning it's always going to be, it's never going to be a negative number for your y. So this one, D, is always greater than negative 5. So I hope that helps. Sun's getting my eyes a little bit. So anyways, I'm going to end this video. Again, if you have any questions, email me at tunkert. Students email me at tunkert.wyndham.k12.ct.us. Thanks for watching, and hope you have a great day.